Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll evaluate these three limits. Let's start with the first one. Limit n approaches infinity, n squared plus 1 over 2n squared minus 1. This expression is a rational expression because it is made up of a polynomial expression in the numerator and a polynomial expression in the denominator. The degree of the numerator expression is 2. The degree of the denominator expression is 2. Since the limit is n approaches infinity, we can simplify this rational expression by multiplying both the numerator and the denominator by 1 over n squared because the degree of the numerator and the denominator is 2. This is a very important concept we need to understand and memorize. Next, we should distribute 1 over n squared into the parentheses in the numerator and denominator. In the numerator, n squared times 1 over n squared is equal to 1, and 1 times 1 over n squared is equal to 1 over n squared. In the denominator, 2n squared times 1 over n squared is equal to 2, and negative 1 times 1 over n squared is equal to 1 over n squared. Now we can use the algebraic laws of limits to apply the limit to each term in this expression in the numerator and denominator. In the numerator, 1 is a constant, so the limit value is 1. We can break up 1 over n squared into 1 over n times 1 over n. In the denominator, 2 is a constant, so the limit value is 2. We can break up 1 over n squared into 1 over n times 1 over n. Next, we can apply the limit to 1 over n in the numerator and denominator. Limit n approaches infinity for 1 over n is equal to 0 because as n approaches infinity, 1 over n becomes equal to 0. I get 1 over 2. This is the value of the first limit. Now we can evaluate the second limit. Limit n approaches infinity, n plus 1 square over n times n plus 2. This is a rational expression because we have a polynomial expression in the numerator and a polynomial expression in the denominator. The first step is to simplify these polynomial expressions. We should expand the terms in the numerator and denominator. We can expand the square by multiplying n plus 1 by itself. In the denominator, we can distribute the n into the parentheses. Next, we can distribute the terms in the parentheses in the numerator using the FOIL method. Next, we can combine the like terms in the numerator. N plus n is equal to 2n. The degree of the numerator expression is 2. The degree of the denominator expression is 2. Since we have to evaluate the limit n approaches infinity, we can simplify this expression by multiplying both the numerator and the denominator expression by 1 over n squared, because the degree of the numerator and the denominator expression is 2. Next, we can distribute 1 over n squared into the parentheses in the numerator and denominator. We should multiply each term in the parentheses by 1 over n squared. In the numerator, n squared times 1 over n squared is equal to 1. 2n times 1 over n squared is equal to 2 over n. 1 times 1 over n squared is 1 over n squared. In the denominator, n squared times 1 over n squared is 1, and 2n times 1 over n squared is equal to 2 over n. Now we can use the algebraic laws of limits to apply the limit to each term in this expression. In the numerator, the first term is 1. 1 is a constant, so the limit value is 1. In the second term, 2 over n, 2 is the coefficient of the term. We can move it out of the limit. As I showed for the first limit, limit n approaches infinity for 1 over n squared is equal to 0. In the denominator, 1 is a constant, so the limit value is 1. In the second term, we can move the 2 out of the limit. Limit n approaches infinity for 1 over n is equal to 0. We get 0 in the denominator as well. I get 1. This is the value of the second limit. Now we can evaluate the third limit. Limit n approaches infinity, negative 1 to the power n plus 1 over n. In this expression, we have n in the denominator. This given expression is a fraction. We can break up this expression like this. We want to break it up like this because we know that limit n approaches infinity for 1 over n is equal to 0. Now we can use the algebraic laws of limits to apply the limit separately to each term. Limit n approaches infinity for 1 over n is equal to 0 because as n approaches infinity, 1 over n will be equal to 0. So the product of this limit and 0 will always be equal to 0. Therefore, the value of this limit is 0. Because no matter what the value of limit n approaches infinity for negative 1 to the power n plus 1 is, the result of the product will always be equal to 0. There's a very important concept we need to understand and memorize for a problem like this one. So this should be the final answer for the third limit. So these are the steps you have to keep in mind to evaluate these limits. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.